Hello, this is Gerald Scarzella, and this is my Understanding by Design unit. This unit is actually for high school students. I'm a high school math teacher right now, and I wanted to do a unit in statistics. And so my goals were to have students develop and employ strategies for understanding and solving problems in ways that leverage power of technological methods to develop and test solutions. That actually comes from the UbD standards that are from 2016, computational thinker. So that's where that comes from. And I also wanted to go into the Alaska Math Standards, which was interpret categorical and quantitative data. And that is actually here as well under statistics and probability in the Alaska Math Content Standards overview. So that's where my unit is based on. And so all the descriptions here is basically from that. I had some difficulty trying to come up with a transfer skill, so I came up with students will be able to independently use their learning to understand that data is continuously being collected everywhere and all the time, and the tools and concepts learned in data analysis will help them make use of information and not be ignorant of being misled with data. The other transfer skill is that we wanted to view technology as a tool for data analysis and decision making. The understandings that the students are going to have at the end of this unit is that students will understand that statistical analysis and data display often reveal patterns. Patterns enable prediction. Correlation and association does not imply causation. Models that are used to draw conclusions from data. Choices in data collection and representation affect interpretation. So those are the basic understandings that I want my students to learn during this unit. The essential questions will be how can data be analyzed? Why do we collect and analyze data? How do you know if your model is a good one? Are conclusions from data valid? How can collecting and analyzing data help you make decisions or predictions? And how do you make and interpret different representations of data? So basically, I want them to do a whole bunch of things with some data, mostly trying to identify what categorical quantitative data is. I'm not going to go over all the acquisition skills, but basically there was a lot of things that they were going to do in this unit that relates to statistics and data. And during this lesson, they are going to be using technology quite a bit. In fact, during their performance tasks, which is right here under stage 2, they need to take a random sample of students at our high school and create a two-way table by summarizing information by gender, male or female, and whether they support a proposal to increase the length of lunch by 20 minutes. In other words, they're going to answer whether they oppose it, support it, or have no opinion. And then from there, they're going to analyze the data graphically and numerically and report their findings. That is basically a categorical data assignment, performance task, and the checklist is below here. It kind of lets them know what they have to do for that assignment, for that performance task. The other performance task had to deal with quantitative data, so this one's also interesting. It says you want to sell your used car and don't know what the listing price should be. Check various sources, Craigslist, classifieds, NADA, etc., and record data on age in years, mileage in miles, and listed price in dollars for approximately 30 cars that are the same brand and model as your car. Analyze the data graphically and numerically to determine your listing price. So they're going to kind of figure out what the other options are out there to buy a similar car like yours, and based off of that, they're going to go ahead and come up with their own price to sell their car. And again, they do have a checklist down here as well about what's expected during that performance task. And so basically, I didn't have a rubric because a rubric didn't make sense to do this. I wanted to make sure that they did specific things during the performance task, and that's why I have this checklist. Now, while they're doing this, they are going to use technology. I did say here that they can use a Chromebook or laptops to create graphs. They're going to use Chromebook and laptop to create tables. They can also use a graphing calculator to determine least squares regression lines, conduct different tests like tests of homogeneity or tests of independence, and basically use their Chromebook or laptop to write a report at the end. I wanted to kind of go over a few minutes about what technology is available to them. One of the things that I have in my room right now is a classroom set of TI-84 Plus CE graphing calculators. These are top of the line, just came out this last year. Texas Instruments have been making graphing calculators for quite a while, and so they've gotten good enough to actually have these really nice ones that have color graphics. The display resolution is not that great, and if you've read some of my posts before, basically they're not the best, but it does do a lot for a small handheld unit. One of the nice things about these calculators is they do have a lot of capabilities. So if I click on Explore Activities, they do have quite a few things, apps you can download and use. Here I'm going to go ahead and choose Statistics because that's what my unit is on. And here we have some apps that you can download and activities you can actually look at to help you learn some statistics. So here's a best class, which one will give you a better score basically. You can do this regression like this unit is describing. We talk about t-distributions here and many more. So there's a lot of good things that we can do with the graphing calculator as a standalone unit. One of the other things I suggest students do as well is use a graphing calculator online. So here is what's called Desmos. It's a graphing calculator that's online. You can go to this website at any time, the www.desmos.com/calculator, and I actually kind of pre-programmed a table of numbers. And so basically what my students would do is they would enter this data into the table, and then they would basically be able to graph it. So if I click on this button, since I already did it, it shows up. There's my graph. And so we want to find out, is there a pattern? Is it a linear pattern? And if it is, we can actually graph it, have the calculator figure out the least squares regression line. And so there it is. There's my nice linear pattern for the data. And one of the things we also do in statistics is look at residuals. And so this has an option to look at the residuals down here on the green dots on the x-axis. So really powerful way to do some math, statistics as well. And so it's called the Desmos Graphing Calculator. But technically, most students I found out would actually prefer using the graphing calculator that's handheld, which is still a very good piece of technology to use for my unit that we're doing in our class. So basically, that's what they're going to do during stage 2 is those performance tasks. And we also have some other things that we're going to do as well, some formative assessments as we go through and try to learn about how to do these segmented bar graphs and two-way tables and things like that, so they have a better understanding about what's expected of them during the final parts of our unit. And as we get to that, that's actually stage 3. And so down here, oh yeah, the other thing that I found, which was really nice, it's not my creation by no means. It was a what's called a Jigsaw Student Rubric. It was made by Exemplars in 2015. And it's just a nice way to figure out if students really understand what they're doing in math. And so they have the different levels of, are you a novice, apprentice, practitioner, or expert in these different areas of math, such as problem solving, reasoning and proof, communication, connections, and representation. And so it's a nice visual about, hey, I really understand what I'm doing in communication, but I really struggle on making connections. And so puts it in words that kids, I think, really understand and can relate to. And then the learning plan, I'm not going to go through the whole thing as well, but it does go over the different areas that we talked about in our text. The where to, where, why, what are we doing, what's the hook and hold 'em during the unit, what kind of equipment do they need to use, where do I revise and rethink during the unit about what's happening, and where do I evaluate, how do I make it tailor-made so students can figure out what to do based on their needs and abilities. And then the whole lesson here is basically just organizing. So basically, I'm not going to go through the whole list as well because it's pretty long, but it kind of goes through a nice unit on trying to figure out, hey, we have data, I want to look at a graph, what can we know from it? And so based off that, that's their hook. And I allow the students to talk about what they think is being displayed, what's being presented, and then we go ahead and have a formal lesson on what it is they're looking at, types of graphs, what can we do with different types of variables and data. And so basically that's what the whole unit is. And so it's a nice statistics unit, I think. It's one of the many things that you could do in a stats class. Again, statistics is actually one of my favorite topics in math. And so I really like to teach statistics at our high school, and we're lucky that we're able to do that. So basically that's my unit, and I hope that you enjoyed listening to it, and I hope that you can make some nice comments at the end. Thank you.